Awesome. Okay, thank you everybody for joining our meeting. Before we get started, we shall talk about some upcoming 12 events. The closest one will be a radio workday at Radio Ranch in Paso. So please check the events channel on the Discord. It's going to be a part two of a Arden workday that we did last time over there. We just couldn't finish some things, so we're going to do stuff again. So there will be some tower climbing and Ethernet runs. I think there's 8 or 9 people already, so I think there will be rides if you're interested. So definitely recommend if you want to get into ARDC, because we will be doing a lot of Arden stuff in the upcoming months. The other thing is we will be doing School Club Roundup. I think that is next week. And School Club Roundup we do every year. It is a radio contest, which school clubs specifically around the states participate in making contests. It is almost, I think it's like a 4 or 5 day event. So we will be posting more info on the Discord. Please stop by and try to make contacts. Even if you haven't used HF before, we will teach you. It is great fun, and we get to talk with a bunch of other schools, and also anyone else can participate. It doesn't just have to be school. So yeah, it's pretty cool. And with that, let's get started.
Cool. Is that my cue to jump in?
Yep.
Sweet. Awesome. Okay, cool. Well, first and foremost, thank you so much for having me. It's kind of cool to give a talk to my alma mater, or the school I went to get my bachelor's degree in electrical engineering. Um, and Yeah, so I was asked to give a talk about Meshtastic, and this is actually a talk I gave at JPL for the JPL Amateur Radio Club. And really, I'm not sure how many folks in the crowd here are familiar with Meshtastic, but I sort of assumed you know nothing about it, and I'm going to try to go through what it is and how to use it and how to get involved. And my call sign, by the way, is N6ARA. Cool. So, quick little outline. I'm going to talk about what Meshtastic is, what a node is, and how the mesh network itself works, what the topology involves, and how you communicate across it. Then I'm going to go over some of the configurations, because it turns out these types of radios have a lot of different settings, and you got to get them right for things to work right. And how you can get a node yourself. And then I'm also going to give sort of a brief overview of the node we set up at JPL. It's nothing super fancy, but it was sort of a fun experiment to see what we could get working around our area. And I'll give a little bit about my experiences with setting that up. And then throwing out some future ideas, because I genuinely believe Meshtastic is it's not only a new cool thing, but it's a whole new area to sort of experiment and play around with. How can I use this communication method in different ways? So I'll go over some ideas I've been floating around, and maybe that might inspire something for someone in the audience today. So what is Meshtastic? In short, it's a long-range off-grid communication system. It's a mesh network topology, which means you typically have multiple nodes. These are independent radios that can all talk to one another and can pass messages between one another. So let's say, for instance, you have one radio over here that wants to communicate and send a message to a radio over here. However, there's no direct line of sight. An intermediate radio or set of intermediate radios between it and the destination can actually pass along the message. And so they sort of form this mesh. And this is a different topology than what you would probably, or what cell phones use, for example, right? Cell phones have, while they do have a quote unquote mesh of towers, all your phones are connecting to these towers, and these towers then pass along the messages and handle all the handoffs. But your cell phone never communicates to another cell phone to send a message to another cell phone, right? So that's sort of the a high level overview of what the mesh is. Now, what's really cool about it, in fact, I think uh, it's a good thing for ham radio, is that it operates on the ISM band. I think it stands for like instrument, science, and medical bands. It's a license-free part of the 900 megahertz band, around 915 megahertz. And while that part of the frequency band can be used by hammer operators, it's also kind of unique in that non-licensed people can use that. So you can use it for texting. You could use it to do even encrypted communications. It's typically used by like instruments and IoT devices and things like that. But it's kind of a cool entry point into ham radio, right? You can hand someone a Meshtastic node or a 915 megahertz radio, and they could start messing with that without having to take the test. And really, I've actually seen folks who got into Meshtastic and started messing with it and sending texts and being like, "Oh, this is kind of cool," and then that became the gateway into getting their ham radio license. So it's really wonderful in that regard. Now, unlike cell phones and Wi-Fi, it's very low bandwidth. So think text messaging. The whole system revolves around sending, I forget what the character limit is, like 200 something odd characters between the nodes. But the other cool thing about it is you can actually do encryption. And yeah, it's completely legal, right? Like in ham radio, I'm sure most of you here are hams know that as part of the test, one of the questions is, if you can use encryption, and the answer is no, you can't use encryption in ham radio. But because this is a license-free part of the band, you actually can. And so this is a bit of a rabbit hole, but there's many different ways you could set up the encryption and actually send encrypted text messages from one Meshtastic node to another, even though it has to pass through other nodes. Those nodes don't have the decryption key to be able to decrypt what the message is, which is kind of cool. Um, it's based on something called LoRa or long range radio protocol. It's I'll dig into it a little bit more in a couple slides, but it's a proprietary protocol, so it's not well known, although it's been reverse engineered by some really smart people. It is closed source in a lot of ways, and that's all implemented in the hardware, not necessarily the software. And right, and so at the Meshtastic layer, that's where all this like, so it's not. So actually, I should say this mesh networking system is not really baked into LoRa itself. It's not part of the radio protocol, but rather all the mesh networking is handled in the application layer within Meshtastic's firmware, and that's like the software running on the node. The other cool things about it are it's open source, so you can go pull the source code and look at how Meshtastic itself works. It's inexpensive in that you can probably build yourself a node for like $5 with parts off Alibaba. And I'll list a couple of available options that you can get from like Amazon and stuff as well. As I said earlier, no ham radio license required, no cell phone towers required. Essentially, it's a off-grid uh, what is it called? Messaging network system that sort of, in that sort of, it relies on the community to keep it working. And so it's been, I've heard people try to sell it as an emergency network system because, like, yeah, if the cell phone towers and Wi-Fi goes down, you could, in theory, pass messages between nodes, many miles away from one another. But I wouldn't rely on it for emergencies. It is not a very dependable method of communication, as I've come to learn. But it is really neat and it is growing. So the more nodes you have, in theory, the better and more robust the network becomes. However, that sort of breaks down after a certain point. I won't get into that just yet. Maybe we could talk about that later. Um, But yeah, and it's kind of cool if you're going hiking, you might be able to use that to see how far out you get and maybe coordinate with people. But I wouldn't rely on it for emergencies or safety. But really, the way I see it, it's just it's a cool way to just sort of experiment with communication methods, and maybe even contribute to the open source project. So how do you actually interface? So how do you actually communicate via Meshtastic? Usually, for most applications, you have a separate radio module. This radio module can talk on the 915 megahertz band and has the implementation of LoRa. And you interface to the radio either by cell phone, so your phone could like Bluetooth pair to these radios, and then you can get notifications through the app that you have a text. Or I've also seen there's a bunch of different radios out there, like pictured here, that are standalone units with their own keyboard and their own little screen. And so you could almost treat it like its own standalone unit, like like a BlackBerry or something like that, if anybody remembers those things. And you can type on it and send messages, but it doesn't do anything fancier than that. You can also have your laptop hook up to it over Wi-Fi. You can connect to these things with a USB cable. There's many permutations of how folks connect to it, but um, most of the time, most people I know will buy a Meshtastic node that has Bluetooth, and you just pair it to your phone, and that's how you can send your messages across the mesh network. So what is a node? And what's really cool is the answer is like there's so many different uh, options of where you could buy nodes and how you could even build them. But at the heart of every single node is a host, some sort of microcontroller or processor that's actually running the Meshtastic firmware and stack, and then some sort of an interface, be it Bluetooth, Wi-Fi, serial, built-in display and keyboard. And that is paired then with a radio that has the LoRa protocol. So you can't just use any old, 915 megahertz radio. It actually has to have in the fabric of the radio chip the LoRa protocol, which uses something called chirp spread spectrum, bit of a tongue twister modulation. And so it's not really a typical modulation scheme that you would find in most ISM band radios. One other thing that's kind of interesting to note here too is that in the United States, Meshtastic is based on 915 megahertz. However, if you travel outside of the United States to another country and you want to bring a Meshtastic node with you, you really do need to check if that country uses the same frequency. For example, in Europe, all the Meshtastic nodes are on 433 megahertz or roughly the 70 centimeter band. Um, so keep an eye out for that. And then the other important thing to note here is that the power output has to be less than 1 watt. And that is sort of a special caveat, and it's especially relevant to everybody here in that you have to keep the power level below 1 watt if you are using encryption and you're not a ham. If you're a ham, you have to drop the encryption. You're not allowed to do encryption above a 1 watt. However, it does enable you to use more power. So you could do like five, I think up to 20 watts, if I'm not mistaken. Don't quote me on that. It's more than 1 watt. But with your ham radio license, as long as you turn off decryption, you can actually push more power and run these nodes much further out. And so that's kind of a cool, neat benefit of being a ham and trying to do Meshtastic. Anyway, so you got to combine these two things, right? Oh, let's see a hand up, I think.
So if you are using it as you mentioned the ham, can you not connect to encrypted node using encrypted messages?
Yes.
Uh,
Or sorry, I think I might have missed I might have missed your question. Can you repeat that again?
yes, like as ham, you can't transmit encrypted messages, so you couldn't like acts are really like four messages that are both encrypted, right? Like,
Ye- Yeah, that's right. That's right. Exactly. So this is kind of a special feature within the Meshtastic app. When you could tell the app, or which then will allow the radio to go to a higher power, depending on what radio you have. By the way, some radios will let you increase the power without turning on ham mode, quote unquote ham mode. If you turn on ham mode, it signals to the radio, or the firmware is supposed to signal to the radio that it's allowed to put out more power, but it automatically turns off encryption. So if you enable ham mode, keep that in mind. However, if you do enable ham mode and you go to the higher power, you then stop listening for and retransmitting encrypted messages. So you effectively fall out of the more popular Meshtastic network and sort of join a ham radio Meshtastic network, which is unfortunately much smaller. That I only know a few nodes in the LA area that are on ham mode. Does that answer your question?
yeah.
Awesome. Okay. Sorry, it's just a little bit hard to hear, but I think I got that. Um, Right. And so, yeah, so a host plus a radio equals a node. Most of the time, like actually, I think the next slide, oh no, not yet. Yeah, you can build them yourself or you can buy them. And I'll show you guys some options in a little bit. So what does the actual interface look like? I think there are a bunch of different ones. The one pictured here is the Meshtastic app for the iPhone, but folks have made Meshtastic apps for Android as well, Mac, Windows, Linux desktop. There's web browser-based Meshtastic clients that you can connect over Bluetooth to a device and use the web browser to essentially log in to your Meshtastic node and pull messages or send messages. There's even a Python command line interface, which I've used for kind of experimenting and hooking in Python into other devices like IoT devices to the Meshtastic network, which is a don't do it. You got to be a little bit careful because, like, don't hook up your door lock to the Meshtastic network because that's a vulnerability and problem, right? You don't want people breaking in or sending messages to it. But it is a fun, cool way to sort of use coding and mess around and see what you can do. Aside from that, yeah, the app typically will pair over Bluetooth. When you pull it up, what you'll see is it'll drop you into the Nodes tab. And listed here are all the nodes that my node that I paired with sees. And so, in particular, what I'd like to note here is this number up here, 249. That's telling me my node, Tiny Router, that I'm connected to here, um, sees 249 nodes on the mesh network. And then, there's another little button over here that you could tap that'll take you to a map. And if the nodes that you hear are reporting their position, which by the way, you don't have to, it's an optional thing. You can report your lat long, and that'll show up in a map. So people kind of know roughly where you are. And sometimes that helps you understand how many hops away another node is or how far you could reach them. It also kind of helps you map out where you could put more nodes and improve the network and coverage of the network. So that's one great benefit of having a map based on the position reporting. Aside from that, within that drop down of nodes, you can actually tap on the nodes and direct message people if you want. However, the most common way I've seen people communicate with it is on channel 0. So there's different channels within Meshtastic. Channel 0, called the primary channel, is considered a public channel, and the encryption key for it is public, so everybody knows the key and can talk on channel 0. And usually it's it's kind of funny because it's a lot like ham radio when you're talking on a repeater. Like the people on Meshtastic are talking about Meshtastic. So they'll be like, oh, I can hear you from this far away. You're this many hops, or anybody copy me in Riverside, or anybody can you see my signal and can you reach me and all that sort of stuff. So that is typically the sort of traffic you hear on there. It is also not filtered, so you're going to get randos and crazy people on there as well. So be careful. You don't know who's on the other end, and really there is no traceability in a lot of this. So that's sort of my caution to the general public. Right. And the messaging interface is pretty simple too. So if you wanted to message someone, I don't think I took a screenshot of this, right? No, I didn't. Okay. Um, DMing is sort of the same thing. Instead of being in this chat channel you see here, you would tap on the mesh node, let's say OHD Solar Node 1. I could tap on them, and that would open up a DM, and I could then send them a direct message. And while my message is encrypted on my end, you end up within the, if I'm not mistaken, within the Meshtastic protocol, you do a key exchange, and then once the keys are exchanged, then you can actually message the other person. And while all the nodes in between you are passing the message along, in theory, they're not able to decode it and see it. Oh yeah, sorry. I think I see a question. Go ahead.
Wonder if the host of each node specifies like how much forward error correction, what kind of spreading factor they're using, or if it's something that a node like adaptively configures based on like how well it's communicating or how well it's hopping around.
Oh man. Yeah, so that's a really good question. And as far as I know, that is not that's not a feature of Meshtastic. I could be wrong. I will say I'm quite a novice with Meshtastic. I don't claim to be an expert. So please do fact check me. But I am not aware of any sort of dynamic either protocol or modulation switching or to improve signal strength between two or more nodes.
So it's something that's kind of set up and like defaulted when someone configures the node. Then is that?
Yeah. So, and that's a fantastic question. So the configurations are actually they are fixed, and there is a lot of them. So the main ones in particular, and I think I'm going to jump into it in the next one. Yeah, the long fast. Okay. So there are different settings you could set within LoRa that I'll cover in the next slide that are relevant to how far it'll go and how reliable it will be, but it is a fixed setting. Along with a bunch of other settings like your encryption settings, your channel settings, your position reporting, your telemetry reporting. You can actually configure your node to send out telemetry that it collects. So anything from like temperature and humidity to, some GPIO pin it's reading, whatever you essentially want. You can configure it to report that. There's also MQTT, so you can actually connect your Meshtastic node to the internet and have these messages then piped out MQTT and posted on the internet, or even tunneled to another Meshtastic node that then repeats it out. And you can essentially connect multiple nodes together over the internet as a backbone, if you will. But you got to be a little careful with that too, because you can accidentally create a lot of congestion with misconfiguration. So to your earlier question, specifically with the chirp spread spectrum settings, there are two key settings within Meshtastic that you can set. One is the range, or the bandwidth or spreading factor. And that varies from the short setting to the medium setting to the long setting. And I think what that really refers to is the I think time, was it time or frequency range that it sweeps across? I don't remember off the top of my head now. If it's bandwidth, it's got to be frequency span. Um, you essentially have those three knobs there, or those three settings for that knob, and then speed or the or the duration of the transmission. So over time, essentially, if you look at the uh, frequency of the chirp over time, you can see that here in this plot as an example, it's sweeping from, I don't know, 450 kilohertz over to 550 or so. And what you can do is you can vary the width of that frequency sweep, and then you can also vary the duration it's sweeping, or the slew rate that it's sweeping across that some fixed amount of time. And the combination of those two things determines the bits or symbols that are being sent. And there's trade-offs, right? The longer you spend transmitting, let's say you set this to slow for the speed, it's going to take a long time to send the message. And especially if you do a long range, so you sweep across a long frequency range, that might help you get further out. But if you're going really slow and you have a lot of traffic on the network, what's going to end up happening is you're going to start having collisions, right? Multiple people are going to be talking at the same time, and you're going to be missing messages or congesting the network because you're just spending too much time actually transmitting. And so and at the time of making these slides, by the way, the most popular setting was range set to long and speed set to fast. I know there have been changes recently. Some people, I think medium fast is more popular now, if I'm not mistaken. But it, it, the interesting thing here is that these settings actually drive, based on popularity, essentially, you end up bifurcating how many networks can exist within an area, right? So if you set your settings to long fast and you turn on the node, you're going to see some set of nodes out there. If you change one of those settings, essentially you're joining a whole new network. You're not going to see anybody on long fast if you're, say, on medium fast. And there's trade-offs, and there's long debates about what makes sense for what region, and even special events. By the way, I don't know if anybody has been to Hamvention before, out in Ohio. I think it's in Ohio. Yeah, Dayton, Ohio. Um, there were like, I don't know how many, 10, like 20, 30,000 hams, right? And this last year, a bunch of people brought, and the previous year to that, actually, a bunch of people brought their Meshtastic nodes, and the network came to a grinding halt. Like you could not send any messages because there were just so many people. And so the folks who were sort of leading the charge of, hey, let's bring some Meshtastic nodes, told the folks at Meshtastic, like, hey, this is a problem. And the folks at Meshtastic actually made a custom firmware with custom settings, specifically for crowded environments. And it was kind of a cool test of, hey, does this work? And in fact, last year it worked fairly well. And I think it was like they ended up using like short turbo or something along those lines. And that was able to handle the large population of nodes around the area. Now, one thing actually I haven't even covered yet is hop count, right? So earlier I said if you have one node that needs to message another node far away and there's a couple nodes in between them, how does that message actually get there? Because if you weren't tracking how many times, and actually, I should say, the way you do that is you track how many times a particular message you hear has been repeated. And so they call that hop count. So let's say I have my node here and I in my settings, you can set it between 1 through 7, how many maximum hops I want to allow that message to take until it stops being repeated. I can, set that in my settings. And in this case, in this example, I say, in my configuration, I set it to 3. If I transmit that message, the next node that hears it will receive the packet, look at the packet, and say, "Oh, this so far has had 3 sorry, the counter is set to 3. I'm going to decrement that by 1 and retransmit it. Then the next node that hears that retransmitted message will then open the packet, look at the packet, see that it has a hop count of 2. It then decrements it again. That becomes 1. It retransmits that. And then by the time it gets to the last node, that the number will be 0, and that last node, in this example, conveniently, it's 0. But it would not rebroadcast it. And it also happens to be the destination. But if I had, let's say, set the max hop to 2, it would have gone to this radio, to this radio, to this radio, and then the hop counter would have been 0. This radio would have been, okay, well, this message is now expired, and it would not retransmit or rebroadcast that message. And you really do this because otherwise, these messages just keep circulating around, and everybody will keep, you could potentially get into these deadlock configurations where everybody just keeps messaging the same message around and around, hogging up the network and creating congestion. Does that sort of make sense?
Yeah.
Cool. Okay. So one thing that's really important here is, if you mismatch any of these settings, right? So when you get a brand new Meshtastic node, a lot of the times not even the frequency or the region you're in is set. So you need to make sure you set all your settings correctly. And again, this depends on, there is no like one configuration setting that everybody's using. It is a very local thing. But for the most part, you have to set your frequency to 915 megahertz, your range and speed. I recommend starting with long fast. That's where you're probably going to see the most people. And then you don't really have to touch encryption settings or MQTT. I would also recommend not starting with ham mode if you're getting into this, just because it's kind of there's a lot more people on the non-ham mode configuration. And then MQTT gateways are a really, really neat thing. So it depends on which settings you're interested in using and what settings your local area has, in particular to MQTT nodes that are reporting to a more popular system like liamcoddle.net. Was there an echo? Oops. Okay. So if you go to liamcoddle.net or meshtastic.liamcoddle.net, this is a website set up by some guy named Liam Coddle. I don't know who he is, but he made a website that sort of aggregates all these Meshtastic nodes and plots them on a map. In fact, I can pull this up here, right? So this is like the Los Angeles area, and there are certain nodes. So this one, for example, Uno 1, happens to have, where is it? Oh, it's disconnected as of an hour ago. The green dot here in particular means that it's hooked up to the internet and listening for packets and putting them reporting them to the internet if people have MQTT enabled for their packets. And if you do that, other nodes that have MQTT uploading enabled will then get uploaded onto the internet and onto this like website. And so to actually set this up and to be able to show up on this map, you do need to configure your MQTT settings as described by this person who set up this server, right? So you have to, set your MQTT address, your username and password, and enable all these things. And if you do that, and set enable, then anybody who hears it that is connected to the internet will upload it to the site. And that's kind of cool, right? Because what that means is, and I'll pick on the JPL node that I've been talking about, is I can actually monitor the health of my node from the internet. So I can like log in and see like, oh, my battery levels are doing pretty great. It starts to tail off at night, and then when the sun rises again, my battery starts to charge. I could see how much air traffic time I'm using up, and even I've been reporting like temperature and humidity, right? So it's kind of cool to see. It turns into like a little weather station. And you can also do some really interesting diagnostics as well if you do that. So yeah, that's just yet another cool feature of the system. Somebody talking?
I think, some other participant on our call has their mic unmuted.
Oh no. Okay, I'll keep going and hope that might change. So how do you join the mesh? So there's a lot of different vendors nowadays. When I first started, there was like 2, 3 kits you can kind of build, but nowadays there's a bunch of commercial uh, pre-made units. So Rockland.com has some really nice options. In particular, I've used the T-Deck. It's kind of crappy with battery life, but it's this cool standalone BlackBerry-esque messaging device where you don't need a cell phone to use it, and essentially has a nice GUI. It's not on here, but in this photo at least. But you have like it'll show you all the nodes, and you can DM them and send text and all that stuff. The LilyGo T Echo is another cool one that has like a built-in GPS, so that position reporting that you were seeing in the maps, you can reference the GPS inside this little LilyGo, and that'll report your position along with whatever messages you want to send to it via pairing with Bluetooth. And those are kind of on the higher end of like costs, like 70, 90, $100 for these things. But the really cheap stuff like the ESP LoRa V3, you can get off of Amazon today for like $22. In fact, I think there's a V4 now available with a much more stable firmware. My personal favorite, however, is the SenseCap card tracker T1000. It's this little radio you see here. It's about the size of a credit card. And actually, did I bring it? Oh, I don't have it on me today. Oh, all right. Usually it's so thin. I mean, it's like maybe 3 credit cards stacked together. It has a built-in battery and like a mag charger and antenna. And the cool thing is you can just like throw it in your pocket and it'll be paired to your phone via Bluetooth. And so if you're walking around and you get a message from someone, or you want to jump on the channel 0 and join the chat room, you could do that without having to like worry about some bulky thing in your pocket or in your backpack. And there's genuinely so many options. Like, I hate to say it, but like Google it, you'll find tons of great options. Look through reviews. Some firmwares are better than others. I have certainly seen some nodes not pick up messages where other nodes sitting right next to it do. So like not all of these perform the same. The other thing I'd actually also encourage folks to do, especially if you like to tinker and if you're a double E or not even, if you like to solder things, you can build your own. So if you go to like Adafruit, you could buy these LoRa radio modules, or AliExpress if you want to go super, super cheap. And you can wire these things together, upload the firmware, and get something going pretty quick. And you can also integrate them with your projects, right? It's another really good use for it. Oop. So one last thing that I at least wanted to mention is the JPL Amateur Radio Club's node experiment. So wow, it was, oh my gosh, a lot of time has passed quick. I felt like last month. I was gonna say like, oh, the other month. No, that was like August 25th. My coworker and I went up on the Mesa. It's this mountain right just above the laboratory at JPL that's used for like radio range testing of various projects that go on here. But the JPL Ham Radio Club has a little spot up there where we host our 2 meter 440 and I think 220 megahertz repeaters. And so I asked the club, like, hey, I want to put up one of these Meshtastic nodes. I got one of these, and it's kind of hard to see it in the picture here. A solar-powered Meshtastic node from Rack Wireless. It's the WizMesh Repeater Mini. And I bought this thing. I had it at home, but the sun doesn't quite reach my house very well. So it keeps running out of battery. Can I put it up on the Mesa up here? And the Mesa has got a beautiful line of sight to the horizon, right? Like you see here down below is the Jet Propulsion Laboratory, and then that's Pasadena and the horizon, and Long Beach way out in the haze. And so it's got great line of sight, right? And so that means I can help become a repeater bridge for many, many nodes. The higher up you go, the better it is, right? And the fact that it's solar powered means I don't have to hook it up to any of the power at JPL, so it's entirely off grid. And I also configured it to be a router, or it was either a router or a repeater, I forget. One of them allows you to essentially anytime you hear a packet, you blindly just repeat it no matter what, unless the hop count is 0. Um, and it, yeah, and so I set that up and let it run for a couple days and found that it became quickly one of the busiest nodes in Los Angeles. Um, the air utilization time was somewhere in the 5 to 6 percentile, which sounds like very little, but that means 5 to 6% of the time this node was busy sending something. And typically, if you get one of these nodes, it falls in the 1 to 3% range. So it was doing some, heavy lifting for the network, at least around the area. And then because I had configured the system to report the battery state of charge, all the metrics that it tracks, and enabled MQTT, I was able to log into the Meshtastic Liam Caudle site and actually track and see how the node was doing. I even I even was use it to see if the batteries ran out because before the last firmware update, if the batteries drained to 0%, it would actually lock out and never come back, and which meant me having to drive up the hill again to go reset it. Thankfully, they've since changed that with a firmware update. But the fact that I had MQTT enabled let me see that and be able to monitor the health of my node. The other cool thing was it increased the coverage across lab. There's, I would say, maybe 10, 15 of us at JPL who who are from the Ham Radio Club and not from the Ham Radio Club, who like Meshtastic and have been kind of keeping nodes with one another and just sort of experimenting. And for the longest time, you would maybe get an acknowledgement that your message went out, because somebody else happened to be in a building next to you with one. But after we put this node up, the whole area was covered. And so something cool that you might be able to do if you can convince someone on campus to give you access to the roof is put up a Meshtastic node and sort of enable being able to set up these nodes, and being able to message across campus. That'd be kind of a cool thought experiment. Personally, and I think this is the second to last slide here. I found Meshtastic to be such a fun new hobby to sort of learn about how to build repeater systems in a sense. One of the things I learned while setting this up was the value of something called a cavity filter. Oftentimes, if anyone here has worked with setting up a ham radio repeater, you would be familiar with cavity filters, which are essentially just super narrow band filters, primarily designed to cut off the transmit frequency from stepping over the receiving frequency on the same band. However, for Meshtastic in particular, I had this problem where at my house I have a 50-watt 2-meter radio, and the antenna for it was right next to my Meshtastic node. And before I had this filter on, I had set up the antenna, and one day I was like, oh, I should hop onto this net, jump onto the net. I'd talk and say hello and check into the net, and then the next day I was looking and checking in on my home node and noticed I hadn't reported anything in over 24 hours, and I was like, oh, that's really weird. And I'm like, oh, maybe it's just some congestion in the network, or maybe one of the other nodes went down and nobody hears it anymore. And then like a week went by, and I'm like, okay, now this is kind of weird. So I opened up, the box where my radio lives, and I try to connect to it directly with a coax to a spectrum analyzer with some attenuation in the middle, and found that it had just stopped transmitting entirely. Like it could not transmit. It was completely deaf, as if like the radio wasn't working. And then it dawned on me the timing of when I had checked into that repeater net, or to that repeater, and when the node died. And it turns out if you put a 50-watt 2-meter antenna next to a little, puny Meshtastic node, and you key up only a few feet away, it's going to cook the RF front end of that Meshtastic node. And that's because one of the harmonics just so happened to line up um, in band and was enough energy, and that harmonic had enough energy to burn up the node. And so not only did I end up separating the antennas apart, but I also realized, oh, a lot of people get around this problem by installing these cavity filters that very, very narrowly filter out anything other than the Meshtastic frequency that you're operating on. So that's kind of like a cool, fun thing that I'm hoping to add to the JPL system soon as well. Um, Let's see what else are there. Oh yeah, and more recently I started a Meshtastic net on channel 0, which kind of feels like spamming, but honestly, the whole channel 0 is being used for fun anyway, and it's all talking about Meshtastic stuff. So on Mondays at 12:30 p.m. On channel 0, we're using the W6VIO, or not, sorry, the JPL Amateur Radio Club node to send out a hey, who can hear us? Please check in. And then folks will chime back, hey, we heard you. And then, I kind of take a roll call or not a roll call. I take a list of all the nodes that I heard and then, post that on the club email. But, you know, I'm sure folks here can probably come up with something more fun and interesting as well. But again, I encourage folks to experiment and try things out. I will say one thing I added to these slides, and this is my last slide here, are sort of forward looking into the future. One thing that's amazing about Meshtastic right now is that the firmware is rapidly growing. I mean, every other week there's a new stable drop or beta drop, and there are more stable ones over longer periods of time. But there's tons of new features coming out, a big community of people contributing to it. There's always new features within the app and even within the comms layer. There's also now a sort of uh, uh, I don't know. I don't know how to put it, but some people didn't like Meshtastic and were like, "We're going to go build our own Meshtastic," called MeshCore, and it is a very different topology. It sort of follows similar to what cell phones do, where all the clients, all your nodes connect via repeaters, and only the repeaters typically will handle traffic and moving them around. It does allow for more hops. It has a lot less overhead, so it doesn't have that sort of congestion problem that Meshtastic has. And it'll work like this firmware you could put on your if you buy a Meshtastic radio, you can run the Mesh Core firmware on it as well, as far as I know, for most of those mesh radios. That said, I encourage everybody to go experiment, get one of these nodes, play around with it, tell your friends, and see what cool things you can do with it, because this is the beauty of having a spectrum available to us. So, with that said, sorry, I don't think I went over time here. It's probably a good time to take some questions, and yeah. See your hand up.
You tried going the DIY route and
Yeah.
you got a LoRa module, but you didn't really know about this whole Meshtastic thing. So you just chose a random spreading factor, and you just started blasting bits out on 950. I was just trying to get an idea of how much chaos you probably caused in a time period.
We need the appropriate sequence.
Yeah,
I
so like not the appropriate sync word, like is the power going anywhere? Are we disrupting a lot of communication? Did we denigrate the signal in any way?
Dude, mess around and let me know, because I don't know that I in a previous life did a little bit of computer security, and I just love finding like vulnerabilities and problems in systems. So you definitely could within probably 1 watt, mess around and find out. But I think the reality is you're sort of limited to 1 watt, and you may be like if you're close enough to another node and you're being loud and sweeping around and doing some bad things and tripping up the LoRa and kind of stepping through the state machine. I believe it has some sort of a built-in state machine where it looks for those sync words and things you were mentioning to start decoding. I'm sure you could trip it up. If anything, you're probably just going to cause it to miss messages from other nodes. But yeah, and also don't take that as an endorsement from the institution I'm from, but just for me personally, it's kind of fun to experiment with these things. Yeah, go ahead.
So yeah, me and the dude who just asked that previous question had like a little project last quarter. We were doing like vehicle health monitoring with like a little like LoRa transceiver module we purchased. And one of the things I noticed is you can include the receive signal strength indicator inside the packet sending. I was wondering because you mentioned there's like a fixed amount of hops you can have. What kind of if there's like sort of some sort of like clever algorithm, or if it'll like hold to see the receive signal strength from the other nodes, if it comes up with the most optimal way of hopping between nodes to the final destination. If that makes sense, what I just asked.
Yeah, and wow, that's a really good question. I don't know of a native way that it does that. Maybe it does, but that definitely could be something I could see someone spinning a custom firmware to do. Um, and now that you mention it, I think there are some, well, I should say this first. Mesh topologies are like their own world. There's so many different ways to form a mesh network, and what you're mentioning is one of the variants of that. I know at some point I remember reading about people wanting to implement something similar because you know, with all these various paths it can take, there's some really inefficient ways messages can be brought around, and the system, in theory, could run some sort of characterization of itself to optimize routing. Um, but I'm not, at least I'm not aware of it doing that. But you know, check me, and I'd be really curious to find out. That is a really interesting thought.
We wanted
Sorry, I
to
wish I had a better answer.
no, that's okay, thank you. We wanted to start messing around with some of the LoRa WAN stuff, but we ended up this is like towards the end of the quarter, and we ended up just like finishing where we were. So, but that's one of the things
Nice.
we kind of wanted to experiment with, I guess.
Cool, dude. That's awesome. Love to learn more how it goes. Any other questions? Oh yeah, go ahead.
How easy is it to trace where the packets are coming from?
So one thing I have found is I don't trying to remember exactly what the details are here. You don't necessarily know the packet that you receive at the end, let's say the person at the destination, when you receive that packet, or actually any packet for that matter, the packet doesn't contain the history of the route that packet took. For the longest time, I thought it did. And because like sometimes you'll see people report like, oh, packet heard by such and such node. And it turns out it's, you know who the last person was to send it to you, but you don't have a trail, a trace route, if you will. However, there is a mechanism within Meshtastic called trace route where you can say, I want to talk to, node, I'm node A, I want to talk to node D. And you can see at least one route, the first route, if I'm not mistaken, where it, I don't exactly remember how it works, but there's some sort of a method where every single node along the way reports back that they heard your packet and how many hops away it was, and then the Meshtastic app will tell you, oh, it hopped from this node to this node to this node to this node. How it does that, I don't exactly know. But yeah, I would say look at the trace route feature. Um, Did I answer your question?
Yeah, thank you.
Okay. Yeah, and by the way, this is part of the whole like I think a lot of the mesh core people were sort of fed up with some of these like missing features and that's why they've been kind of spun up a separate effort to sort of address being able to do the sort of things you guys have been suggesting and talking about. Any other questions? Hard for me to see the tiny screen here. Cool. Oh yeah, go ahead.
Connected up to the Bay Area mesh network?
Was the question, can you connect to the Bay Area Mesh Network?
Yeah,
Yes, if you are in the Bay Area, that you absolutely can. It depends again on what configurations there are. There's also methods using MQTT where you can effectively quote unquote tunnel into the Bay Area, but that requires both ends to set up that sort of tunneling, if you will. Um, I personally have not done it. I don't know how to do it. It also can cause a lot of problems if you don't configure it correctly. In that, let's say, for example, I set up a node in Los Angeles with like now there's like over, I don't know, 700 nodes. That screenshot I took is old. Um, if there's 700 nodes here and there's 700 nodes in the Bay Area, and you create a tunnel between the two where any packets heard by one get repeated out in San Francisco, you can cause all sorts of chaos. So it is possible, but it needs to be done in a careful way to not congest the network. That's at least my understanding of it. Yeah. But if you are, say, by the way, if you're set your radio to long fast, which is sort of the most popular, at least as far as I know, and you're in Los Angeles and you're chatting on there and you drive up to the Bay Area and you've left your, configuration on long fast, you're going to start seeing other long fast radios there too. There's no sort of like handoff going on between the two or different networks that you need to worry about. Great question. Yeah, go ahead.
Yeah, one more. I was wondering if there's been any sort of like discoveries or like instances where someone like discovered Meshtastic being used to do something like criminal.
Criminal. I personally don't know of anything, but I have been curious about it too because it is effectively unregulated in that, like, it is a private messaging network system. And you don't really, and it's not centralized, so you can't easily stop it. You could jam it up if you really wanted to uh, stop it or slow it down. Um, but yeah, I don't know of anything like that. Unfortunately, it probably is a matter of time until something like that does happen.
Yeah.
Um, yeah. Yeah, it's also it's kind of interesting, right? Because you would think that this is kind of new and unique, but it sort of isn't too. We've had, say, for example, APRS for years now, right? And APRS is sort of similar to this in that there are sort of hop counts and configurations on APRS messaging being passed around. And while you need a ham radio license to do it, you don't anybody can fake a call sign or do anything like that and use APRS. Um, but at least I'm not aware of anything like that. If anything, by the way, in the APRS scenario, uh, is a good example of what can happen when there's bad configurations and congestion too, right? I personally have messed that up on a high altitude balloon I built while I was at Cal Poly Pomona. I set I forget what the settings were. It was like 2.2 or 1.1 or one of the worst configurations for APRS you could possibly set, which auto repeats out if anything is heard. And so I launched my balloon and it was sending out, lat long altitude and some other telemetry. And every single APRS station that heard it repeated it, and it caused a huge congestion problem throughout at least the LA area. So my guess is if you do see it, it's probably done by accident by, bozos who didn't configure it things right. Like me.
I have a question.
Yeah, go ahead.
In class, we're learning about modulations.
Mhm.
Type of modulation. Um,
Yeah, that is a great, yeah, that's a fantastic thing to be learning about. And I think in this case, uh, if I'm not mistaken, CSS is the modulation scheme. It is it is sort of a more unique modulation scheme where you sweep frequency over, some time width. Um, but at least that's what I understand LoRa to be. I know there's many others from like, frequency shift keying and binary phase shift keying and you name it for modulating the signal. But as far as I know, LoRa is CSS. And somebody could correct me if I'm wrong. I might. It's been a little while since I did information theory and RF. Does that answer does that answer the question?
um, well, I
Is
know,
there some more specific?
I guess I could look up CSS. But
Yeah, yeah, I would say look that up. And yeah, that should hopefully answer more questions. Yeah, go ahead.
How difficult would it be to get a packet from one side of the country to the other?
Oh, that's a cool idea. There are, as I do know that there are not I wouldn't say contests, but there are people who try to go for the like long distance record. And if I'm not mistaken, the long distance record are like in the hundreds of miles now, like 300 miles or so. Um, my guess is it is certainly possible if like 7 hops, like 7 times 300, like you might be able to get coast to coast if you got enough people who are willing to set up highly directional antennas, aimed both ways and maybe with the extra 5 watts with the ham mode plus good propagation conditions because 900 meg does propagate to some extent depending on certain conditions. It may be possible. Honestly, man, I try it. I love that question so much. Like it's like such an engineer's question of like, well, how far can we push this thing? Yeah. Any other questions? I think we're at time here. Cool. Well, thank you all so much for having me. This is a lot of fun. You all asked a lot of really great questions, and it was a pleasure to talk to you all.
Thank you so much. Could everyone give him a round? Now that was a great presentation. A couple of us are like already interested in Meshtastic stuff, and I think like few of us have nodes already, and we
Oh,
have
sweet.
one sort of cheap solar repeater that's just sitting on top of the building. But
That's great.
unfortunately,
Oh
we
man, I
don't
didn't
really have
know. That's
connection
awesome.
onto sort of like the North Bay and like the Bay Mesh yet. Just because like there's this one sort of radio dead zone in like Paso. So we're trying to fix that, seeing if more people are gonna, be interested in it, and maybe put some gorilla nodes up somewhere in trees. But
Yeah.
yeah, and I hope this presentation inspired more people to join Meshtastic. So thank you so much.
Yeah, yeah. Thank you so much for having me and keep me posted on how things go. I'm
Yeah,
really
of course.
curious. Like this is, and by the way, what you just said is exactly one of my favorite parts about it, which is like, ooh, I want to get this node to talk to this node or this region to talk to this region. Like, how can I convince someone in this area to be able to like bridge us? And it's
Yeah.
just there's some like weird social aspect to it that's a lot of fun. And so yeah, keep doing what you guys are doing. That is so cool.
Thank you so much. Have a great evening.
You too. Thanks so much. Bye bye.